A and B run around a circular track whose circumference is 150 meters. When they run in opposite directions, they meet every 5 seconds. But when they run in the same direction from the same point, they are together every 25 seconds. What are their velocities? Take a moment to think about the problem. If you want to give it a try, feel free to pause the video and come back once you're ready to see the solution. Alright, we are going to use algebra to solve this problem. I'm going to show you how to analyze and manipulate the variables to get the answer. And along the way, I will be giving some tricks and shortcuts for those who are answering this in a multiple choice format. So it will be faster and more efficient to answer, which is perfect for board exam takers. Okay, now, let's start with assigning some variables to represent their velocities in meters per second. Let VA be the velocity of A, and let VB be the velocity of B. We know from the problem that the circumference of the track is 150 meters. When A and B run in opposite directions, they meet every 5 seconds. And when they run in the same direction, starting from the same point, they meet every 25 seconds. Now, let's analyze the case where they run on opposite directions. Let's assume that A is running faster than B, and after 5 seconds, they will meet at this point. Note that A covered more distance since, again, he is running faster than B. As you see, the total distance covered by both A and B in those 5 seconds must be the entire circumference of the track, which is 150 meters. So we get that dA plus dB is equal to 150 meters. Now remember that velocity is equal to distance over time, so we can say that distance is equal to velocity multiplied by time. Writing this in terms of runners A and B, we get VA multiplied by T plus VB multiplied by T is equal to 150. Since T here for both terms is the same, 5 seconds, we can write VA plus VB all multiplied by 5 is equal to 150. Simplifying this, we get that the sum of velocities A and B is equal to 30. Now, if this problem is given with multiple choices, like in most entrance and licensure exams, you can pause right here and test all the given options. The key here is that the values in the choices should satisfy this equation. And if only one option will give us the sum of 30 meters per second, then you can stop right away and have that as an answer. So, for example, if we try to add the velocities in option A, we get that the sum is 25 and not equal to 30. So we can eliminate option A. Also, adding the velocities in option D will give us 22 meters per second, so we can eliminate option D. Here, I intentionally made options B and C have the sum of 30, so we can proceed to the next scenario. But it is great to know that we have now narrowed down the choices into only 2 options. Now, let's consider when A and B run in the same direction. A is the faster runner, so A will eventually catch up to B. The key here is to understand what it means for A to catch up. Here's how we can visualize it. A and B start at the same point on the track. Since A is running faster, the gap between them starts to increase as time goes on. After 25 seconds, A catches up to B at the same point on the track, meaning they meet again. For A to catch up to B, A needs to cover more distance than B. The extra distance A covers to catch up is exactly 1 lap of the track, which is 150 meters. This means that after 25 seconds, runner A will have run 150 meters more than runner B to meet at the same point again. Or we can say that the difference between their distances covered is 150 meters. So writing down in terms of their velocities, we can say that VA multiplied by T minus VB multiplied by T is equal to 150. Since T here for both terms is the same, which is 25 seconds, we can write VA minus VB all multiplied by 25 is equal to 150. Simplifying this, we get that the difference of velocities A and B is equal to 6. Now, you can stop right here and test the remaining options to see which satisfies this new equation. And it is obvious that option B will give us the correct answer. So the velocities of runner A and B is equal to 18 and 12 meters per second, respectively. As easy as that. If you want to solve the answer without the use of the options, you can continue with the solution by adding the 2 equations that we derived, This cancels out VB, giving us 2VA is equal to 36, which will ultimately give us the value of VA, which is equal to 18 meters per second. Now, substituting this value to either of the two equations we derive, we will get VB equal to 12 meters per second. And there you have it. If you enjoyed this problem and want to see more math problems solved, don't forget to like this video and subscribe to our channel for more content. If you have any math problems that you'd like us to solve or discuss, feel free to drop them in the comments section below. We love hearing from you and might feature your problem in a future video. Thanks for watching, and good luck on your exams.